Okay, so today in class we did this lab that involved this reaction here. And the iron thiocyanide is actually red, and this side is clear. So, of course, we can't have just ions, so we used iron nitrate and potassium thiocyanide to get the ions that we needed. And that means that the potassium and the nitrate were spectator ions. They didn't participate in the reaction. So, what we saw in the first part of the lab is that we force the equilibrium very, very, very far to the right. And we did that by increasing the amount of iron so that it really wasn't an equilibrium. Pretty much all of the thiocyanate was used up to make iron thiocyanate. So what we were able to do was make kind of a calibration curve, or not a calibration curve, but maybe a standard curve is a better name for it. And we made a graph, a standard to compare it to, of absorbance versus concentration. And we assumed that we can only make as much iron thiocyanate as thiocyanate. So what we saw was we measured the amount of light that passed through the red, and we got different points, and then we put it in a line of best fit. So that was the first part of the lab, was to get this standard of comparison. And we could do it because this is red, and there's a direct relationship between the amount of light that can pass through a substance and its concentration. We also could do it because we had iron. We increased the concentration so much that it forced the equilibrium to the right, and that meant that the amount of thiocyanate was equal to the initial amount of thiocyanate was equal to the final amount of iron thiocyanate. So, in the next part of the lab, you were given an unknown, and basically all you had to do with that unknown was figure out, based on the line of best fit. Okay, so the line of best fit was this was the absorbance, and this is the concentration. And using that line of best fit, I gave you an absorbance value. So for the unknown, we said that that value was equal to 0.104. And you could substitute in here and solve for what the concentration should be, or the measured concentration. And that was question number 1 of the analysis. In question number 2 of the analysis, you had to compare it to the real concentration. So it was 0.0005, and I can't remember right now if it was 5.3 or 5.7. So just hopefully you wrote it down, and if you didn't, just use 0.0005. And it turns out that gave us a ton of error. There's lots of different reasons for this error. We think that the main reason is probably the calibration, and also the fact that we're using such small quantities of these substances. That cuvette was very small. So that's going to mean that being slightly off could have a big impact on our data. So in the first part, we pass the light through, we get a standard curve right here, and then in the second part we look at an unknown and see where it falls along that curve. So this part didn't have very much to do with equilibrium yet. The next part is the part that really had to do with equilibrium. So I'm going to do that as a separate podcast.